Okay, I said in the last video we're going to move on to the third type of problem here, but I lied. There's just something else I want to do before we do that. And let's take a look at a question like this, okay? The limit as x goes to -2 of x squared. It's just another style of limit that I want to make sure you know how to handle. Say something like this. Plus 2x over x plus 2. So this one here, it's kind of a fraction plus another fraction, right? And we haven't really, so far we've just been dealing with the limit of like a single fraction. And you may wonder, how do you handle this? Well, what you want to do is you want to use algebra to get a common denominator and put it all together as one fraction, and then do it like we were doing before. This one here, it looks, you actually already have a common denominator, don't you? X plus 2 is on the bottom already, so we can write it right away as a single fraction, and it's going to be x squared plus 2x on top. And now it's kind of looking like it was before, right? When I put -2 into the bottom, I get 0. And when I put -2 into the top, I get 4 plus -4, which is also 0. So this is of type 2, 0 over 0. So maybe I should try to factor it. The top, there's a common factor of x, right? So let's pull out the x out front. And look what we have left over. We have an x plus 2 there. So we can cancel those guys off. And we're left with the limit as x goes to -2 of x. And that's fine. We just put -2 right in there, and we get an answer of -2. So that's how you do that kind, okay? Let's try another one, kind of similar to that. And then, just so you know that if you ever have like a sum or difference of two fractions, you should probably combine them up first, and then use the technique of factoring, or maybe rationalizing. How about something like this? Limit as x goes to 1 of 1 over x minus 1 minus 2 over x squared minus 1. Well, this is a difference of two fractions. Let's combine it up. This time the denominators are not the same, are they? We have to do a little bit of work this time. I think first of all we should maybe factor the second denominator here. X squared minus 1 is going to become x minus 1 times x plus 1. Okay. And how can our common denominator is going to be then this, right? X minus 1 times x plus 1. This guy is already good, but this guy here, we need to multiply the top and bottom by x plus 1, right? So let's do that. So it becomes x plus 1. 1 times x plus 1 is x plus 1. And the bottom is x minus 1 times x plus 1. You know, this fraction I just wrote is the same as 1 over x minus 1, right? Because if you cancel those x plus 1s, you get back to where we were. And that's kind of like a little verification for you to know you're doing things right. Okay. Now that we have both denominators being the same, we can put them together now and write it as a single fraction, which is kind of our goal, right? X plus 1 minus 2, I'll just do that right away. That's x minus 1, isn't it? And the bottom is just the common denominator. And now look, those x minus 1s here, they cancel. And we like that, because now the limit is an easy kind of limit, and we're just going to be able to put the number in on the next step. So let's put number 1 in, so we get 1 over 1 plus 1, so 1/2. So the answer for that guy is 1/2. Good. How about this one? Let's erase this. One second. Let's say we do this one. Limit as x goes to 2 of 1 over x minus 1/2 all over x minus 2. Maybe you've never seen that kind before. Well, when I put 2 in here, I get a half minus a half, which is 0. In the bottom, I get 2 minus 2, which is also 0. So this is of type 0 over 0. So we probably want to do some factoring or rationalizing. Certainly there's no roots here, so we're not going to do rationalizing. But how do we factor this? There's nothing really to factor. Well, the thing is, this needs to be simplified into a single fraction, right? This is kind of like a double fraction now, isn't it? Do you guys remember this important algebra rule? What if I have one fraction over another fraction? This is so important. One fraction over another fraction. How do you handle something like that? This is like your main fraction line, and then you have a fraction on top and a fraction on the bottom. Well, maybe you remember from way back that to divide fractions, remember a fraction line means divide. So to divide fractions, you multiply the bottom by the reciprocal. So that means you take the top, leave it alone, and you multiply by the flip of the bottom, the reciprocal of the bottom, so d over c. And then you can just bring those together and write AD over BC, right? So it's important to remember that little rule. Well, let's try to work on this a little bit. Let's get the top. Let's maybe just put brackets here just for clarity. We're going to leave the bottom alone right now, but the top we can break it in, or you can make it into a single fraction. So the common denominator is going to be 2x, right? So it's going to be 2 minus x over 2x. And the bottom is still x minus 2. Now if it helps you, you can think of x minus 2 as being over 1, all right? Because right now we've just set ourselves up to use this little formula here, right? So that's the limit as x goes to 2. You keep the top the same, but the bottom is going to be flipped. So it's 1 over x minus 2. And now it's really important to remember another little rule of algebra is that if you ever have, like, let's say you got something like x minus 5 and 5 minus x. Did you know those cancel? Those cancel to give negative 1, don't they? How can you see that? Well, what if I factor out, I'm going to erase this part because I'm going to run out of room. Why don't we factor out a negative 1 from the top? So if I factor out a negative 1 from the top, I get negative x plus 5, right? In the bottom, I'm just recopying. And here I can switch the order, right? So I get 5 minus x over 5 minus x. And there we go. Those 5 minus x's cancel, and I'm left with minus 1. So basically, I'm just trying to remind you of this little algebra rule here, that if you ever have something like a minus b over b minus a, that's equal to negative 1. Okay? Kind of surprising, but that's true. And right now, look at this. We have 2 minus x over x minus 2. Maybe before I'll cancel, I'll just write them as a single fraction, okay? So I get 2x times x minus 2 on the bottom, and on the top I just have 2 minus x. Now the point is, these guys here, they cancel. They don't leave 1 behind, they leave a negative 1 behind. So what am I left with? The limit as x goes to 2 of negative 1 over 2x. And now I'm happy because this is an easy kind of limit. I can just put 2 right in there. So I get negative 1 over 4. And that's the answer, okay? So I think you were pretty solid on these two types of limit questions. So let's move on now to the third kind of limit, which is kind of the tricky one.